Topic: waves. A wave is defined as a disturbance in a medium in motion transferring energy without the permanent transfer of the material medium. A wave can be either mechanical or electromagnetic. Electromagnetic waves. These are waves that do not require a material medium for their propagation. As the name suggests, electromagnetic is a combination of electric field and magnetic field. They do not require a material medium for their propagation. Example I said earlier: light waves, X-rays, ultraviolet rays, radio waves, visible light, infrared, etc. Mechanical waves. These are waves that require a material medium for their propagation. That is, they need something to push them. Example: sound, water, waves in ropes and strings. There are two main types of mechanical waves. 1, transverse waves. 2, longitudinal waves. A transverse wave is a wave that travels perpendicularly with the vibrator or the propagator. They can be polarized. That is, they can be passed through openings and they continue traveling that way. Transverse waves include waves in ropes, sound waves. They travel perpendicularly. That is, the angle there is angle 90 with the vibrator. That's the meaning of perpendicularly. Longitudinal waves. These are waves that travel parallel to the vibrator. They cannot be polarized since they cannot pass through openings. The main difference between transverse waves and longitudinal waves in their direction. So for that reason, transverse waves travel perpendicular while longitudinal waves travel parallel. Terms in describing a wave. Number 1, amplitude. This is the maximum displacement of the wave particle. Frequency. This is the number of cycles or oscillations completed in one cycle. Frequency is related as F equal to 1 over T, and it is measured in hertz, Hz. Number 2, wavelength. This is the distance between two successive crests or troughs. Wave speed. This is the distance the wave particle travels with time, denoted as V equal to lambda over T. Wave period. This is the time taken for the wave particle to complete one cycle, and it is denoted as T equals 1 over F. Lambda represents wavelength, A represents the amplitude, X represents the horizontal displacement of the wave particle, YT represents the time or period of the wave. Question: a wave particle has a frequency of 2 times 10 to the power 4 Hz and a wavelength of 0.2 centimeter. Determine A, the period of the wave, T. B, the wave speed, V. Solution: since F is 2 times 10 to the power 4 Hz and lambda equal to 0.2 cm, you have to convert that 0.2 cm to meters, 2 times 10 to the power minus 3 meters. Then T equals 1 over F equals 1 over 2 times 10 to the power 4. When divided, will give us 2 times 10 to the power minus 5 seconds. B, V equals F times lambda, which is 2 times 10 to the power 4 times 2 times 10 to the power 3 minus 3. When multiplied, will give us 40 meters per second. A wave diagram that has a horizontal distance of 0.6 meters and 3.5 cycles, and the frequency is 2.5 times 10 to the power 3 Hz. Determine the period of the wave. B, the wave speed. Solution: frequency F equals 2.5 times 10 to the power 3. The period is unknown. and lambda is 0.6 divided by 3.5. That is 3.5 cycles. So the wavelength is 0.17143 meters. Hence, T equals 1 over F equals 1 over 2.5 times 10 to the power 3. When divided, we give you 4 times 10 to the power minus 4 seconds. B, wave speed V equals F times lambda, which is 2.5 times 10 to the power 3 times 0.17143. When multiplied, we give us 428.575 meters. Question 3. Determine the frequency of the wave if the wavelength is 2 times 10 to the power minus 4 meters. And also determine the wave speed. Solution. The period is 0.6 seconds, which you can see in the diagram, and the wavelength is 2 times 10 to the power minus 4 meters. A. Frequency is 1 over T equals 1 over 0.6. When divided, will give us 1.67 hertz. B. Wave speed equals F times lambda, which is 1.67 times 2 times 10 to the power minus 4. When multiplied, we have 3.3 times 10 to the power minus 4 meters per second. Equation of a plane progressive wave. A plane progressive wave is given as y equals a sine open bracket 2 pi x over lambda minus 2 pi ft, where a is the amplitude, lambda is the wavelength, f is the frequency. Question. A plane progressive wave has a frequency of 2 times 10 to the power 3 hertz, a wavelength of 0.04 meters, and an amplitude of 0.5 meters as well. Determine the equation of the wave. Solution. Since f is 2 times 10 to the power 3 hertz, lambda is 0.04, and the amplitude is 0.5. Using the equation of a plane progressive wave, which is y equals a sine open bracket 2 pi x over lambda minus 2 pi ft, y becomes 0.5 sine open bracket 2 pi x over 0.04 minus 2 pi times 2 times 10 to the power 3t. When multiplied and simplified, our final answer becomes y equals 0.5 sine 500 pi open bracket x minus 80t when you factorize. Question 2. A plane progressive wave is represented as follows. Y equals to 0.7 sine open bracket 0.01 pi x minus 2000 pi t. As you can see, calculate A, the maximum displacement of the wave, B, the wavelength of the wave, C, the frequency of the wave, and D, the wave speed. Solution. Compare the original equation with the one given to us in the question. The amplitude is 0.7 by comparison. B, since 2 pi x over lambda equals 0.01 pi x will cancel pi x, so 2 over lambda equals to 0.01. So lambda becomes 2 over 0.1, which is 200 meters. C, comparing 2000 pi t with 2 pi ft, we have f equal to 2000 over 2, which will give us 1000 hertz or 1 kilohertz if the answer is to express in kilo. D, the wave speed is expressed as f times lambda, which is 1000 times 200, which will give us 2 times 10 to the power 5 meters per second. That will take us to properties of waves. Reflection. This is the ability of waves to rebound when obstructed on their path of propagation. For example, when water is flowing through a gutter and immediately is obstructed by a plywood, it is observed that the water rebounds back. That property is known as reflection. Number 2, refraction. From the word refract means that the wave has the ability to travel from a medium to another medium of different densities. Example, water flowing from shallow level or shallow ground to deep ground, or water flowing from deep ground to shallow ground. Number 3, diffraction of waves. This is the ability of wave particles to bend around obstacles. Number 4, interference. This occurs when two waves superimpose in their path of propagation. That is, when two waves are traveling from a source and they meet each other, either constructively or destructively. Types of interference. A. Constructive interference. This occurs when two waves traveling from a source cancel the effect of each other constructively. To illustrate, two persons running from a source, and all of a sudden they collide. The effect of both of them will be cancelled automatically. B. Destructive interference. This occurs when the two waves cancel the effect of each other and each get into the crest and trough at the same time. Polarization. This is the ability of wave particles to pass through openings or slits. Example, when a wall is perforated and perforated in another position, light traveling from the first opening can pass through the other opening. That shows polarization. An instrument used to study polarization is called a Polaroid, which has openings where waves can pass through. That brings us to the end of the topic, waves.